Okay, so we have a few minutes left. Standardization ideas. I think it's good that you as professionals should also be comfortable with knowing where to look when I need something before we look at what we actually want to look at. So I inject this idea. So who actually manages the internet, right? Kind of thing, right? So there are a few standardization organizations you should know about. Any names you want to drop? Yeah?
Internet Engineering Task Force.
Yeah, cool. Yeah, whom else? I sent you use Wikipedia. Yeah. Yeah. So they're quite obvious, right? So they're nearly on the slide set. Yeah, who else? Internet Engineering Task Force. IETF. IETF, that guy is here on the left. Yeah. Whom else? Whom should we know about as programming professionals and cloud technology practitioners? Econ, yeah. Who the heck is that?
Internet Consortium of names, assigned names and numbers.
Correct, yeah. What do?
They decide, they deal with IP addresses mostly.
And what else? Yeah.
Top domain names.
Yeah. Yes, that's right.
They are
domain name services. So they do IP addresses, domain names. What else?
They manage those 13 top routers.
Okay, yeah, that's right. So they kind of run the internet to some extent, yeah, but they manage one different kind of number as well.
I was going to ask you which group was he talking about? I couldn't hear him.
I was talking of ICANN, Internet Consortium of Assigned Names and Numbers, right? Is it? And we agreed that they manage IP addresses. Yeah. So if you want to have a private IP, those are the guys to talk to. Well, indirectly anyway. Domain names. What else did you mention?
They are managing the top routers.
Routers, right. Right. They're managing routers, 13 top-level routers. We talk about this in other sessions as well. But they also manage port numbers, right? Port 80, port 443, and so on. Those privileged ports. That's something they decide what they are associated with by default. Of course, you can abuse them, but you're not supposed to. And those are the guys managing this one. That's correct. Cool. So that's good to know. ICANN, remember those guys. IETF, we'll talk about them in a second. And what else? Anyone else? I think W3C is something, World Wide Web Consortium. They are all working on web standards above HTTP. Not HTTP itself. That falls into the IETF responsibility, but higher level things like semantic web, Sparkle, like a querying language for web pages, and so on. So a lot of, I think CSS is managed by them as well. So all that kind of beautiful stuff that sits on top is generally .3. The kind of IETF is kind of the linking pin between this very high level World Wide Web related aspects and the internet itself. And that's where the IETF is where the HTTP protocol in particular sits, and they generally publish everything in terms of request for comments originally. And the idea is quite neat. The request for comments concept is or was originally about, hey, I have an idea for the protocol. I put it on the web page. You guys have now a few days or months or whatever. I don't know what the time frames are for this purpose to comment on this, right? What do you think about this protocol? Should we do it, right? And this idea then has basically been adopted and shaped the IETF more systematically. That it's a more rigid body around it, and that they publish requests for comments for new protocols that are deemed then for experimental purposes. And they can then be tested or adopted or tried out for some time. And if there's no significant challenge against it, and if they become adopted, then they become standards. So I think there's a requirement of having two independent implementation of a given protocol by third parties as a minimum requirement for it to become a standard, and no significant challenge to the concepts. So you have different statuses. Informational RFCs, that just say, hey, here's some information you want to share. Then there's the experimental track, that is, here's a new standard, what about that one? Current best practice, that's not about standards, more about how you should do things. Then there's the standards track, of course. That's the one those are the standards we need to look at and know about to some extent. And then there's the historic track, that's all where the historical stuff is kept as well. RFCs are always published in ASCII, so it's really, really nice, very low threshold for adoption and looking at it. But of course, one of the challenges is that RFCs or standards change over time, right? So they need to deal with versioning in a weird, well, not in a weird but interesting way. It's about updating certain RFCs, but also obsoleting them, right? So over time, things change. You think about versions and so on. And if you want to get a definite overview of the standards that are currently adopted, it's kind of more like an overview page. If you like, I'll probably post that in GitLab as well some stage. You can have a look here. So, and you find so internet standard, draft standards, and so on. And it's all the IETF standards that are relevant or not, and some of them are incredibly old, right? So, for example, if we look at the why not the Internet Protocol, September 1981, right? So it's a standard that's still active, basically. And you also see the relationship in what it actually does. Well, it obsoletes RFC. So that's how you read it. The RFC 791, and it obsoletes the RFC 760. It's updated by the RFC 1349, and so on, right? So all the relationships are kind of managed there. And if you browse through, it's quite a bit of standards. So file transfer protocol, for example, if we still were to use this is how where it's specified, and so on. Quite a number of different ones. Time protocol, we're just talking about NTP. This is specified here, if I get it right. Okay. Reverse address resolution protocol. So all the kind of different protocols are really in this kind of structure are managed and provided. But now let's look a bit more in detail, of course, at something that makes sense to us, right? So coming back to REST, managed by IETF, is a successor of HTTP, and it's laid out in standard RFC 7230. So let's bring up this thing. I feel a bit like a bureaucrat, but I think it's really important that you guys get comfortable looking at this stuff firsthand. In fact, homework for you, read one of those things, and I'll tell you which one. Just to get a feel of what you need to be dealing with. If you're out in the field and someone says, have a look at this specification, what do you think, or implement it? Okay, top left, Internet Engineering Task Force, of course. The request for comments ID 7230 named, and then the main title here, Hypertext Transfer Protocol HTTP 1.1, message syntax and routing. And it again shows on the top left which RFC is obsoletes, meaning abandons, so meaning don't look at those things again at all, and which ones it updates, means you need to read those as well and read this on top of it, right? So there's a delta where some certain revisions done in this document, but the other documents still are still valid as well, right? So yeah.
One thing I'm wondering about is was the RFC created at the time the hypertext transfer protocol was created?
No, before. So it was before. Yes. So you saw that. Yes. That was more at the grounding setting when the internet was standardized. So there was initially, I forgot which university, as usual. They were basically sitting down thinking, okay, well, how do we ensure that there's an initial standard, kind of seems to work, we provide the implementation on the Unix basis, run this, we suddenly have this internet magic. But how do we deal with progression over time, right? With changes over time. So that was the basis for founding this engineering task force, to kind of say, okay, this is the standards body that lays out all the protocols and formats and so on that we're going to use over time. So it's a bit of a convention that you need to buy into. But that's the thing, if you want to deal with cloud or web technology, you want to know about how those guys work, or at least what they publish. Please?
Why is the request for comments 7?
Right. Okay. So yeah. So they give them IDs in order of receipt, right? So they get injections. So you can send a request for comment, for example, in there. In principle, well, it's a bit more complicated than this. There's certain staged levels and so on. But fundamentally, you say, hey, I have this cool new protocol. It's way better than HTTP. Let me send it in, and let's see who wants to adopt it, right? Perhaps it becomes the new big thing in the internet. And then we get associated unique identifiers. It's a sequential identifier. There's no magic there, right? It just happens so that over time, of course, the numbers increase, right? If you look at the earliest one, we had like, let's take a very old one, the Internet Protocol 791, you know, that was a few days ago, right, 1981. And if you look at the bottom here, it becomes a bit richer. Right, the Internet Printing Protocol, right, so has the RFC number 8011, right, so 8011. So Internet Printing Protocol, that thing is basically you want to connect your printer to the internet and want anyone to print on it. That's the kind of protocol you need to enable, so third parties can print on it with, you know, so. But this is very recent, see, for example, January 2017, right? So it's an ongoing process. But the numbers are just sequentially. Of course, you don't need to learn by heart, but they are just unique identifiers again. Okay, so this is part of the standards track, so that's actually an accepted standard. It has experienced a few updates in this document, but fundamentally it's still the main standard core body. The authors are on the right side. And if you see, for example, that guy who came up with REST is one of the core authors of this standard, Roy Fielding, along with a few other people, usually associated along with the affiliation. He's working for Adobe, it appeared, or at least he worked in 2014. And the other guy worked for Greenbinds, I believe. Okay, so those documents look like this. You have some sort of abstract that highlights terminology. What is, you know, what does HTTP stand for? What does UI stand for, and so on. Kind of a bit of boilerplate thing, copyrights, of course, what you expect. And then there's a table of contents, a lot of different, basically the whole standard, how it's described, right? And of course, varies by standard and what it's about, but fundamentally that's the layout. They're using, you guessed it, hyperlinks to actually link between different elements of the documents. This one, for example, lays out everything that you need to know to understand the internet and its workings. And I'll just highlight a few things. For example, it highlights uniform resource identifiers. You want to learn how those things look like? Well, you look there, right? So it looks at message body. It looks at how to calculate the contact length of a body in HTTP, for example. Which kind of compression does it support? Can you compress content, right? Using gzip and so on. What are the standards that need to be supported? And the point is here, if anyone complies, so if anyone wants to use HTTP, they need to support those features. All that kind of stuff that's in here, basically in there. So, and that's quite rich. So any browser will be quite challenging. And it's in fact so rich that they decided, hang on, that's going a bit too far. We need to move a bit, spread this out a bit. And they actually have sub-documents. So it's kind of a document family here that describes different aspects of HTTP. So this document itself describes syntax aspects. Then there's semantics, content, conditional request, blah, 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 blah. So, and the one for us that's interesting is the 7231. And this one lays out the principles of REST in particular. And finally, we get somewhere that hopefully, well, makes a bit more sense. And we come back to this in a very second. So, so that's how you read those documents, right? In fact, what we are interested in is method definitions. I'm just going to page 21. And here is something that probably is more comfortable for you. Again, in the initial slide about the protocol, I mentioned that a request in HTTP starts with a GET usually, right? We can also have a POST request. You guys know that as well from, yeah? Do you know that from some sort of web development 101 course? First year web development? Do you have such a course here? You know it, yeah? Yeah, that's right. But did anyone hear about post requests, get requests, and things like that before? You, yeah, you guys, whatever. The second year, the actual group I'm interested in, not you guys. So, no, okay, good. Okay, then we go into this more detail. But fundamentally, those are kind of the methods that are specified for doing things. We get back to it in a second. What I wanted to get you here is not to confuse you and show you ASCII text, which is fun, but actually to know where to look if you want to know more about standards. And I would actually recommend you to read one of those just to get a feel of how rigid our discipline needs to be in terms of standardization. Okay, right. So let me see what's the most sensible approach of addressing this. So fundamentally, coming back to REST with the standard, we are have a standard now that allows us to specify any sort of interaction with the web server by means of its URL to describe the resource, and methods to describe the changes you want to do. So how does it work in practice? Let me draw a bit. What the standard says is, well, you have, I'm running HTTP here, so you most likely will not get support for your browser anymore, but yeah, whatever, so we'll just deal with this. Then we have some sort of host name .org/, and then we had the path. Remember that URI had a path component, and this path component represents the resource, well, it can represent the resource. Let's assume we want to talk about a resource descriptor we want to manage students. Then this would be the root descriptor for managing the resource students. So what we want to be able to do is to, for example, access a given student. Well, you generally have an identifier. It's also encoded in the URL. You guys can't read this yet, but it probably makes sense to you later on. So you want to be able to use the path in a kind of query sense to access specific resources. So on a given server, for a given resource, for a given resource root, meaning a collection of all students, basically, you want to access, for example, one specific one. This could be a classical uniform resource identifier, because it uniquely identifies student 1 out of the resource students on the host so-and-so. What you would get as output is usually something like this. Sorry for all the bit sections, just put feedback here. So what do we get here? So it's a very crude representation right now. So so the idea what I wanted to represent there is you can now query or interact with a resource using a URL. You specify the URL, and you get some sort of standardized output there. In this case, I try to emulate JSON. That went morally wrong. For example, what did I get wrong in terms of my JSON notation? Yeah?
Forgot commas and quotes.
Exactly, right? I forgot everything that's super important. That is the quotes around pretty much everything that's a string, and the commas to separate the values, or the entries rather. But fundamentally, this is then provided by this service. And this is uniform with respect to the resource that you're managing. So if you access student 1, 2, 3, 4, 5, or 999, or whatever else, this structure needs to be uniform. And this structure is specific, the body is specific to the service you're using, but the way of addressing it is highly standardized, right? So that's the way you do it. So cool. Now we can access individual students. Is this thing parsable? Very parsable in principle, right? So it's same pretty much like an object, right? So you have kind of a key that indicates an ID and then a value. Key is the name, value is Lars in this case, and key is study, and value in this case bprog, bitsec, I don't know, whatever else, right? So while it's specific to the service you're using, it's uniform within the service. So the idea is that, of course, any language pretty much allows for easy parsing of JSON nowadays, being JavaScript, of course, but also Go, you name it, right? You have a comment?
Why didn't you write parse, for example,
You could model it this way if you make your identifiers names. Yes, that's sometimes I'm not 100% clever, but it's totally possible. And I'll show you tomorrow how you can actually do it, right? So we actually do it in Go a bit, so you'll see how it works. But fundamentally, yes. But the idea is that you use URLs to navigate to specific resources. That's the key, one of the key things here. And in addition to that, you not only want to, of course, see resources. That's what we know from the internet. That's very boring and straightforward. You actually want to be able to modify them as well, right? And this is where the methods come into play. So I think I have a set of methods here. There you go. And if you have a resource, assuming you have a student with the ID 1 and the name Lars, and you want to modify it, so that's, you send a GET request here. You got this one out. Now you actually want to change that student. Well, So what I did now is basically, this would be a modification request. You take the same structure, you modify the name of the student into last two, which is probably not a proper name, but for the sake of argument, let's deal with this. And the same study and so on, and you want to modify this. So now we have multiple methods that we can use to operate on it. So the default method is of course a get. That's what you would have with any web page. Again, this standard here is an extension of the common web standard already that you use. It just means that most of the stuff is simply not used by anyone, but we can use it for our purposes. We're building web services. But we have a few other methods as well. So we have get, we have, let's ignore head for now, we have post, we have put, delete, and that's the main four ones that we actually need to be dealing with. And if you pay attention to databases right now, what does it remind you of? Yeah, to some extent, right? So there's four fundamental operations that we have, 4 to 5, depending on who we want to argue with. Basic operations that we do on any entity, any object. What are the 4 fundamental operations we can do on this?
Couldn't hear you.
What are the 4 fundamental operations that we can do, should, computationally do on any object? I go with you, because I know.
Insert, delete,
Yeah, cool. Yeah.
update,
Yeah.
and select, show, select.
Yeah. So display, yes. So that would be select basically, right? Cool. What would your answer be?
It's the same, just with create as well.
Yes. So what's the acronym you generally use if you want to get one level higher from?
CRUD.
Yeah, exactly, right. CRUD. Did you guys hear about CRUD anywhere? In databases, CRUD, C-R-U-D. Okay, what's CRUD about?
Basically, all the operations you need to modify data. You create data, read data, update data, and delete data.
Right? Everyone got this? That's it. Any data, there's 4 operations you can do it. You can create it, you can read it, display, show, select, whatever, update it, update in SQL, and delete data. Surprise, surprise. So if you have a system, you want to have a comprehensive management of data, those are things you want to think about. There's an argument as if you want to consider search as one of the components nowadays as well, to retrieve an argument, to retrieve data, so SCRUD. But that's a bit far-fetched, whatever. But the point is, any system that deals with data needs to have these 4 functionalities embedded, and voila, you have them here as well, right? If you understand those 4 principles, you can see that it's quite straightforward. We have a get method, we have a post method, which is basically like what does post correspond to if you read the description? Anyone but Carl? Yeah, okay, it's not easy. It's a create, okay. So, so posting is creating something. Put, create, read, update, delete. What is put like?
Update.
Update, right? It's changing something that's there already, right? Replace all current representation in the current slot, and delete, voila. It's the final one actually cleaning up, right? After your stuff. And that's by the 4 fundamental methods that we can actually send. And then this whole thing, so, okay, that's what would be the request side. So if we decided that I want to change a given resource, which kind of method would I need to use on this one, in this request? Put. Yeah, put, right? We're here in put. Put would be the one. If the resource wasn't existing, what would I need to do? Which one?
Post.
Sorry? Yeah, but what's the method?
Post.
Post, right? It would be post. And what the difference is there mostly is there's 2 aspects to it. I mean, post and put are often confused a bit. I just mentioned right now. Generally, in a post, you would not provide the ID because the ID is server provided, right? So you send it to the core resource, and they said, hey, I want to add this new student here. And as a response, you would expect the ID for the new student.
If you try to put, what will happen if it doesn't exist?
Exactly. So that's what we come back to. Exactly. How do we deal with feedback, right? So we didn't talk about this. Very good point. Status codes. HTTP status codes. We're coming back to those guys. Which status codes do you know from the internet? Yeah.
404.
404, the most famous one, right? What does it stand for?
Not found.
Cool. Not found. What else?
503.
503. Okay. What's that about? Okay. Cool. I have no clue either. Okay.
It's access, permitted access, and no access. Like you don't have access
Is that 503? Oh, okay. Cool. All right.
Server
If you have any
and
question, ask
ladder.
them. Sorry again?
Server and the ladder.
Exactly. So we come to the classes of errors in a second. Yeah, that?
401 not authorized.
Correct. Right. And 403. What is that? I don't know.
418 IMT plot.
That's a nice one. Yeah. So I need to talk about this one. Yeah. There is apparently they have humor, but yes. So we'll bring this back in a second. That's right. Good point. So fundamentally, we have 5 groups of status codes in as a response. So every request that you send, generally you would expect a 200. What's 200 again?
Success.
Success. Okay, right. So it's the okay status. Yes, even written there. Wonderful. But you have a few. So even if you can't memorize all those individual return codes, you probably shouldn't if you want to stay sane. You want to know what the groups are roughly about, because the status codes that are returned have, give you an indication of the meaning, right? 100 means it's informational. I never saw one of those anyway. 200 means, okay, things worked out, pretty cool. 300 means something that needs to be redirected. That's usually about having an outdated resource and being asked to redirect to a new resource, like 302. You sometimes, well, you don't see it because usually your browser intercepts that. If it receives a 302, it will redirect to the new resource automatically for you. But if you, for example, run a web page and you want to redirect to a different resource, assuming you have a domain name and want to redirect it to a GitHub page, how that would work on your provider, you would provide your GitHub page, and what they would internally do, run a 302, basically redirect you via this status code. It would basically, if there's a request to your domain name, the response would be 302 with a changed address, and then the browser would automatically navigate in this direction. So that's quite straightforward. 400 is client-side error, and that's the key thing. You did something wrong. 500 is server-side error. It's not your problem, the server has something wrong, right? So if you get a 500, it means, yeah, screw that, something's wrong on the server. If it's a 400, well, your request is malformed, your browser is outdated, your client application doesn't work, whatever else. And those are the main ones we're concerned with, because they're super helpful for debugging later on. If you write those services and deal with them, if you have a 500, you know, okay, server-side issue, 400, client-side issue. And that's incredibly helpful to know those things in distributed systems. So, so we probably won't get much further than this. But tomorrow I'm going to, looking more practical, how can we use it, demo it a bit, and then see how we can perhaps use it in Go as well. And that will open up opportunities to do it in your assignment. Any questions so far, even though we haven't quite finished? Who thinks I talk too fast? Yeah? Who thinks I'm too quiet? No one, okay, too fast. All right, cool. Yep, see you tomorrow then, 8:30. Please. Thank you.
I maybe have one question.
Hang on. Yeah.